Ladies and gentlemen, in the previous two videos, we've talked about how to test a point to see if it was a solution to a system of linear equations. And to do that, we simply plugged that point into both equations and see if it made them both true, both. Working in one was not good enough. Then, in the second video, we looked at what that looked like on a graph. And of course, we found that a solution to a system of linear equations is simply the point where the two lines intersect. So when I ask you to find the solution to a system of linear equations, you're looking for that point where the two lines cross on a graph. So let's look in depth at that a little bit more. So here we go. Here are two equations. Y equals negative 2x plus 5. Y equals 4x minus 1. Let's find the solution to this system of equations. So we're going to start by graphing. We'll graph the red equation, negative 2x plus 5. We'll put a scale of 1 on our graphs. Don't forget that scale matters. So my y-intercept is 5. My slope, negative 2, rise, run, down 2, run 1. So here we go with our line. So here is the first one. Then we'll switch over to the blue. Y equals 4x minus 1. Y-intercept negative 1. Slope of 4. 1, 2, 3, 4 over 1. Well, looky there. That happens sometimes. Whereas we graph, we actually find the solution as we go. We have found that point where the lines intersect. We know it's right here. This is the solution. So 1, 3. Now, we want to make sure we're right. So to test to make sure it's right, we want to plug it into both. So the y is 3. We want to know, is it true? Negative 2 times 1 is negative 2. Negative 2 plus 5 is 3. It is a solution to the first. And plugging in the y of 3 and the x of 1, we want to know, is it a solution here? 4 minus 1 is, that's a 1. 3, it is a solution there. We did indeed find the solution to the system of equations. The point 1, 3 is the one and only one, I might add. That is the only point that exists that will make both true. All right? So again, finding a solution to a system of equations is doing what? I hope you just said finding the point where the lines cross, finding the one point that makes both equations true. I want you now to pause the video, and I want you to solve this system of equations. So right now, pause the video and graph these two and find the solution. Alright, I hope you have paused the video and you've actually found this. Let's check your answer. Again, we'll count by ones. Hopefully you labeled your scales. Oops, let's get rid of that little mark. So, my y-intercept is 3. My slope, up 1 over 2. Remember, rise over run. And here is my first graph. And my second graph, negative 3 halves x minus 5. 1, 2, 3, 4, 5. My y-intercept is negative 5. From there, down 3 over 2 Man, we're not even in the same ballpark right now. What do I do? Well, remember, we can go up and left as well. Aha! Did it again. We found that point where they cross. And where was that point? Right there. That solution. 1, 2, 3, 4, -4, comma 1. Of course, we're not satisfied with that. Plug it in to make sure it works. The y is 1. The x was -4. We want to know, did it make it true? Well, half of -4 is -2. -2 plus 3 is indeed 1. And plugging it in this one, want to know, does it make this true? That's a question mark, by the way, if you've been wondering what the heck he's been writing on there. -3, if I treat these fractions, -3 times -4 is positive 12 over 2. 12 divided by 2 is 6. 6 minus 5 is 1. Boom. We did find that solution. Now, let's practice one more, and then you will be experts at solving systems of linear equations by graphing. Again, this is one method, solving a system by graphing. So, to graph these, well, again, we could make a table of values. I prefer, because I'm a stellar algebra student like you are, to solve the equations for y and put them in slope-intercept form. I'm going to subtract 2x from both sides, leaving me y equals -2. I'm going to leave this one 5 minus 2x, just to show you that it really does not matter. When I go to graph this, again, we'll count by ones. When I go to graph this, my y-intercept is 5. The number without the x is your y-intercept. My slope is -2. Write that as a fraction, so I have my rise over run. -2 over 1. Rise a -2, run 1. And here is the first line. The second line, you graph. Pause the video and you graph the second one and find that solution. Hopefully you paused it and you found the solution. So here we go. We are going to solve for y. So I'm going to subtract 3x from both sides. That's an x. That's going to leave me -2y equals 4 minus 3x. I now have to divide by -2. Remember, when you divide in an equation, you have to divide each term by that. That's going to leave us a positive y equals 4 divided by -2 is -2. -3 divided by -2 is a positive 3/2 x. Y-intercept, -2. Slope, up 3 over 2. Well, looky there. We did it again. We found that solution as we graphed. Our solution is that point where the two lines intersect, that point right there, which is the point 2, 1. Are we done? Are we satisfied? Of course not. We're going to plug it in to check. So the x is 2, the y is 1. 2 times the x is 2. The y is 1. Does it work? 4 plus 1 is 5. Boom. Plugging it in here, the 3 times the x was 2, minus 2, the y was 1. Does it equal 4? 6. 2. 6 minus 2 is 4. It works. We are systems of equation solvers by the graphing method. Have a great day.